Hi everyone, I'm very wired on coffee, so I thought I'd make a video to document my wildness on coffee. This is my beautiful girlfriend. Say hello, Pookie.
Hi guys.
Kiss. Okay, off the stage, you.
No.
Anywho, guys, I'm wired, so we're gonna do a physics problem. As you can see, we have a 1 meter wire, and we're basically asked what is the radius of this wire. So, what is the radius? Not big R, little r, right? What is the radius of this wire if we took a cross section of it? That's what we're trying to find today. So how you want to approach this problem is that we know that resistance equals 0.22 ohms. That's what we're given. We're also, this might not be explicitly given to you, but hopefully in a table, the constant of proportionality for resistance, which we call rho, or I think it's the resistivity constant, something like that. It's 5.6 times 10 negative 8 ohms times meters. And we know that the length is 1 meter, so what is the radius? That's what we're trying to find, and it requires you to know this formula here. It basically says that the resistance is equal to that constant of resistivity, right, that's found experimentally, times the length of the wire times the area of a cross section. And what this means, the area, is that you cut a little section of the wire and you find the area of it. In this case, it would be a circle. So hopefully you know how to find radiuses of circles, which we'll get to later, but let's just solve first for area, and then we'll worry about finding the radius, because I know if I can find the area of a circle, I can find the radius of it, and that's what we're going to try and do here. So it's pretty simple. I mean, everything's in the units we want. We have meters, ohms, ohms times meters, so everything's good to go. Let's plug everything into this formula. Let's rearrange it such that area equals ohms length of the wire over radius, right? Just a simple flip-flop of the variables in the fraction there, and helps us solve for what we're trying to look for, unknown. Let me grab a calculator. I'll be right back. We know that area is going to equal 5.6 times 10 to the negative 8 ohm times meters times the length of the wire, which we found to be 1 meter, over the resistivity, which in this case is 0.22 ohms. And the reason that this formula works is if you look at how the units cancel, ohms cancel, meters times meters, meters squared, that's an area. So when we find the area, it's going to be, let's see here, 5.6 times 10 to the negative 8 times 1 over 0.22. Hopefully you should find the area to be very, very, very small, 2.54 times 10 to the negative 7. That's actually a really cool pattern. Look at this. I've never seen this on a calculator before. If you notice, it goes 5, 4, 5, 4, 5, 4, 4, 5, 4, forever and ever and ever and ever and ever. I never really noticed that my calculator doesn't do that, so thought I'd point it out. Can you tell I'm really like wired? I feel like high, but I drank like probably 30 something ounces of coffee. Like my brain is flowing right now. It's not great, but that's life. What can you do? Okay, let's just quickly review the area of a circle. So we know that the circumference is the derivative of an area function for a circle, and we know that the circumference is 2 pi r, so we take the integral of that. I'm just doing this for fun. You guys all know what the area of a circle is. Pi r squared. That's the area of a circle. Hopefully you know that. Hopefully you do. Literally all we have to do is plug in the area, solve for radius. So this is going to be square root of a over pi equals r. Not big R, that's resistance. Little r, that's radius. Okay, so let's go ahead and find that. Square root of the area, 2.54 times 10 to the negative 7 over pi. And we're going to find that the radius is 2.84 times 10 to the negative 4, and that's going to be in meters, okay? And hopefully you can see that the units cancel here. Area is in meters squared. You square root something squared, it becomes just the base unit, and we're going to get that R equals that. And from the problem, it looks like 2 sig figs, so maybe just shave off the 4 here. Call it 2.8. So that's how you solve that problem. Hopefully you guys enjoy it. I don't know where my girlfriend went. I'd have her join us here, but unfortunately not. So have a wonderful day, everyone. Bye-bye.